Hello everybody, welcome to our group. Today we'll cover two chapters, which is chapter 20, linear programming, and chapter 21, functions. Our captain is Hà Linh, and his other members, Thu Uyên, Hoàng Dương, which is me, and Minh. This is chapter 12.1, graphical inequalities. What is graphical inequalities? Linear inequalities can be plotted on a graph. The result is a region that lies on one side or the other side of the straight line. Here is some example of linear inequalities equation if you already forgot. Here you go. So, how to graph inequalities? First, graph the equals line, then shade in the correct area. There are 3 steps. Step 1. You need to rearrange the equation so y is on the left and everything else is on the right. Step 2. You plot the y equal line. Remember, make it a solid line for y less than or equal to or y greater than or equal to, and a dashed line for y less than or y greater than. Step 3. Shade above the line for greater than or below the line for less than. For example, we have y is less than or equal to 2x minus 1. Step 1. The inequalities already has y on the left, as you can see here, and everything else is on the right, so no need to rearrange. Step 2. Plot y equal to x minus 1 graph. It is as a solid line because y is less than or equal to. It includes the equal to. So it is a solid line. Step 3. Shade the area below because y is less than or equal to. Here another example. Y divided by 2 plus 2 is greater than x. Step 1. We will need to rearrange this one. So y is on its own and on the left. So we start with y divided by 2 plus 2 larger than x. We subtract 2 from both sides. So we will have we have y divided by 2 is larger than x minus 2. So and we multiply all by 2. So in the final answer we have y is greater than 2x minus 4. Step 2. Now you plot the y equal to x minus 4 as a graph. Remember, it is as a dashed line because y greater than does not include equal to. Step 3. You shade the area above because y is greater than. So you choose really special cases. Look at the table here. This shows where y is less than 4. Notice that we have a dashed line to show that it does not include y equal 4. This one doesn't even have y in it. It has the line x equal 1 and is shaded for all value of x greater or equal to 1.
In chapter 20.2, we'll talk about more than one inequality. Instruction: when you have to show a region that satisfies more than one inequality, you graph all of them on the same grid, and the region that satisfies all of them is the intersection region of the solution of those inequalities. Here is an example. Example 1. On the same grid, show the region that represent each of these inequalities. 1. Y less than or equal to x minus 2. 2. Y more than minus 3x plus 5. First, graph the inequality y less than or equal to x minus 2. We will graph it as a solid line since the inequality is less than or equal. And because of that, we will shade the area below. Similarly, we'll draw a dashed line for the second inequality, y more than minus 3x plus 5, and we will see that the solution for this is the intersection region we can see on the grid. Here's another example. On the same grid, we'll show the region that represent each of these inequalities. You can see 3 inequalities below. First, we'll rewrite the first 2 inequalities. 2x plus 3y more than or equal to 12 will become y more than or equal to minus 2 over 3x plus 4. And the second inequality will become y less than 2x minus 1 over 4. Now we'll graph the inequality y more than and or equal to minus 2 over 3x plus 4. Since the inequality is more than or equal, we'll draw the solid line and shade the above area of the grid. Since the inequality y less than 2x minus 1 over 4 is dead at less than, we'll draw it as a dashed line and shade the below area of the grid. And for the third inequality, x less than 4, since it's dead as less than, we'll draw as dashed line. Draw the related equation x equal 4 when see that the origin also satisfies, so we'll shade the region which is containing the origin. And we can see that the region that satisfies all of the inequality above is the intersection region of the solutions of all the 3 inequalities.
So next chapter, 20.3, linear programming. So the definition of it, a linear programming is a method to achieve the best outcome, such as maximum profit or lowest cost in a mathematical models whose requirements are represented by linear relationships. So these are some examples of linear programming. So there are practical situations that give rise to inequalities that can be shown on the graph. Solving problems in this way is called linear programming. So here's an example for you. A boat trip costs $20 for adults and $10 for children. Suppose there are X adults and Y children on the trip. A. There must not be more than 10 people on the trip. Explain why X plus Y is less or equal than 10. B. The money taken for tickets must be at least $120. Explain why 2X plus Y is greater or equal than 12. C. Show the region satisfied by both these inequalities. And D. What is the smallest number of adults that should be carried? So you can pause here to solve by yourself, or else let's move on. So here's the instruction. A. The total number of passengers is 10. The total must be 10 or less, so X plus Y must be less or equal than 10. For B, the total number of dollars taken is 20X plus 10Y, and this must be at least 120, so 20X plus 10Y must be greater or equal than 120. And divide by both sides by 10 to get 2X plus Y is greater or equal to 12. For C, negative numbers on the axis are not needed, so you have to draw the graph. So first, draw the lines with equations X plus Y is equal to 10 and 2X plus Y is equal to 12. The first crosses the axis at 10, 0 and 0, 10. The second crosses the axis at 6, 0 and 0, 12. Shade the regions that are not required, and the solution must be in the unshaded region R. So you can see on the graph here, the unshaded region R is the white region, and that is the answers for the problems. And D, the smaller x coordinate in this region is at 2, 8. X must be at least 2, so there must be at least 2 adults.